Ron, thank you very much. My name is Anton Umnikov. I'm a principal solution architect at Redis based in Toronto, Canada. So the same way as ChatGPT and OpenAI totally turned around industry and made AI accessible to everyone, there's a whole bunch of new frameworks that would let you build things with ChatGPT fairly easily without sometimes doing low or no code, sometimes doing just a few lines of Python code. And unless you've been living under the rock, you probably heard the term Retrieval Augmented Generation, right? The whole idea behind it is you're not only using large language models such as ChatGPT, but you're also using things like vector database and tools to scan your own documents, scan your own websites, and make ChatGPT aware, or large language model aware of content of these data that is normally private to you or your organization, right? And thanks to tools like LangChain or Llama Index, it's really easy to build. So if we look at the hello world level of Retrieval Augmented Generation project that would use OpenAI with Llama Index, we literally talking about what it is, 5 lines of code. Like one of them is import all the dependency. Another one is let's read all the files that are in my data directory, then invoke some sort of vector store, and then we'll query those documents, right? Let's do a little demo that does exactly that. I have a notebook here that does exactly this hello world, but instead of reading data from the local file, we're reading it from the web, right? We're reading the article that from CNN.com that talks about some Disney plans and how they've been canceled in Florida, right? The date for this article is May this year, so definitely ChatGPT is not aware of that. The cutoff date is September 2021. So there are just a couple of cells that I already run, installing dependencies and supplying OpenAI key. Other than that, it's exactly the same 5 lines of code. Right. The first one is to load the data, in this case, from the web page. And the second one is just to query the data using the query API, right? And it tells us that according to the article, Disney is canceling plan to build a 1 billion office complex, blah, 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 right? Let me do one more little thing, and instead of doing print result, just showing you what's in the result object. So you would see it's not only the result that we see on the previous cell, we see also a whole bunch of information in terms of where this data is based on, what exactly was fed into the large language model so it can answer this question and so on, right? But for Hello World application, talking with your own data, that's a pretty good start for just 5 lines of code, right? You can take this notebook, put a bunch of your own documents that you can find on the web in here. That's a list that it takes as an input, run it and start asking questions without even know of how OpenAI works, what the underlying API and so on. So tools like Llama Index really make it really easy to build retrieval augmented generation, or at least to start with those. Now, would you deploy this solution in production? Most likely your answer would be no, and rightfully so, right? But let's talk about retrieval augmented generation first, right? The traditional way of searching for the data and interrogating the data, your private data or public data, is retrieval only, right? You can think of Google, traditional Bing, your SharePoint that gives you access to your internal material. It's search only, right? On the other hand, you have large language models such as ChatGPT Pulp, by themselves, they give you answers only about the things they know, things they were trained on, right? So the question, the holy grail of retrieval augmented generation is, how do we make data internal to your organization or very recent data? How do you make this large language model aware of this data, right? There are a whole bunch of reasons to do that, right? Fine-tuning the model or training the model on your own data is possible, but probably very expensive, right? You cannot feed the entire document or set of documents that you have into the prompt because it's large and you very soon would run out of token limit of your large language model, right? So what do? You combine vector embeddings, vector database, and the first step of retrieval augmented generation is you search for the vector database and your large language model and your private documents to find the relevant chunks of information, right? And then I did the second part of the demo. Then I showed you the code of the response object, right? It literally gives you, hey, this answer was based on these chunks of information. So vector database finds the relevant pieces of information, you feed it into the large language model, and large language model operates based on that, right? So three major components. You have embedding generation, you have vector database, and you have text completion large language model. In this case, that's OpenAI, right? In the demo that you just saw, right, that's OpenAI embedding engine, ADA. It's a GPT 3.5, like for your large language model. And by default, Llama Index would use simple in-memory store, so it's definitely not scalable to the production level. You limit it to the memory of your notebook instance in that specific case. So let's try something more sophisticated, more complex, right? We keep the overall flow the same, but let's deploy production ready. It's probably a stretch, but close to production, similar solution on Azure. And to do that, I'm going to the my GitHub repo, and I'm just doing Terraform apply, right? This repo would deploy solution very similar to what you saw in the notebook, but it would use Azure OpenAI for embeddings. It would use Azure Cache for Redis Enterprise, which is a vector database native to Azure. It would use Azure OpenAI for completion. You'll have a little Azure Web App. So basically everything you've seen in this little notebook will be available to you as a web UI hosted entirely on Azure. So while it's running, it would take 6 to 7 minutes to complete. Let's continue with our slideshow. So if you move in this kind of solution, simple solution that you did with 5 lines of code into production, like you immediately have a whole bunch of challenges to solve. Right? How about scalability and high availability? Like this notebook cannot handle more than one user. It cannot handle more than 50 gigabytes of data altogether, right? How about availability of 3 nines or 5 nines, like for your system, for your vector database component, for your OpenAI component? How about storing 1,000 or 1 million documents, right? We did it just with one. How about security? Security for your infrastructure, security of your individual components. You might have organization-specific requirements. For instance, I work in Canada. Pretty much every single enterprise customer of mine have data residency requirement that data about Canadian users, Canadian customers should stay in Canada, right? I cannot do it with ChatGPT because their servers are somewhere in US, but I can do that right now with Azure OpenAI because it's recently became available in one of the Canadian regions, right? How about compliance? Like we already named few: PCI compliance, HIPAA compliance, GDPR, and so on, right? Again, every single component of your system should be compliant to to that one. And there might be some secondary requirements. How about querying your data, maintaining the chat history, caching your responses, and so on and so forth. And list goes on and on and on. So we just moving it one step at a time, a little bit closer. Like the Terraform script that I just ran, it's part of the GitHub repo that is listed here, but essentially it deploys the entire stack in your Azure account. So in one click or one Terraform apply, you would have application that deals with your personal data. It would put it in the blob storage. It would invoke Azure OpenAI deployed within your account, Azure Web App deployed in your account. You don't deal with Google. You don't send data through the public internet, and so on and so forth. Not exactly the landing zone, but which I think Kyle was talking about yet today. You can think of that as one of the modules within your landing zone deployment on Azure that does closed loop for retrieval augmented generation with all the components being on Azure. You need Azure Cache for Redis Enterprise layer tier to enable vector similarity search, which is now part of Redis. But other than that, it's all standard Azure components, including Redis Enterprise, right? Redis Enterprise is a first tier service on Azure, and all the compliance, all the security guarantees that Microsoft gives for you applies to Redis Enterprise as a vector database, right? So vector database, you do need vector database for retrieval augmented generation. Basically, to talk to your own data, you need vector database, right? I want you to think about vector database as combination of two, vector and the database. Vector itself is fairly straightforward. Like my kids are in high school, they can probably figure out cosine similarity math on their own, right? If you go a little bit deeper, a little bit more complex, again, there are well-known, well-publicized algorithms to do approximate search or full flat search across multiple vectors, right? If you have two vector databases that give you different results on the same query, probably one of them should not be in a software business at all, right? So vector part is, again, straightforward, right? But implementing that at scale with scalability, performance, high availability, and compliance, that's the hard part. That's the database part that is hard to do right. So regardless of the fact that I'm working for Redis, I think there are like now kind of two classes of vector database solutions out there. One is your native vector first databases. Pinecone is a great example, right? They have fantastic vector engine. They have fantastic enablement, and I really love like watching their materials, right? But they have some catch up to do in terms of databases, in terms of scalability, in terms of compliance. Right. On the other hand, there are vendors like Redis who already been in database business for a while and just adding the vector similarity search to their portfolio. Right. I think these kind of vendors has better chances of succeeding because, again, between vector and database, vector is easy, database is hard. Right. And vendors who already figured out the database part has a better chance to do that right, do it faster. In terms of what Redis can do for you as a Redis database, yes, security is there, high availability is there, and so on. But things like integration with tools like LlamaIndex and LangChain is important as well, right? Just declaring yourself a vector database would not let LlamaIndex or LangChain to work with you out of the way. We have dedicated group that does just that. Right, building integration with all the ecosystem around there. So the same goes with all the provisioning and security vendors. Like we work with Terraform, we work with Terraform, HashiCorp Vault in terms of observability. Again, a whole bunch of plugins for all the enterprise tools that your enterprise most likely using already. right? And again, vector database is a vector database. There's not that much differentiators there, right? The differentiator for Redis, as I see that, is we're established vendor with a whole bunch of security, compliance, and other things already figured out. And we just letting you to do vector search on top of what you're already using with Redis, right? In terms of compliance, again, if you'll go to trust.redis.com, you would see a whole bunch of certifications that you already have, right? If you need vector database that would be HIPAA compliant, so you can store your medical data in there. Azure Cache for Redis Enterprise is there. It's available. You can take it. If you want just to dip your toe in the water and see what you can do with Redis, again, the same Redis engine, Redis Vector engine, you can run on your laptop or even inside the Google Colab notebook. Now, there are some additional use cases not necessarily related to vector database, vector similarity search that Redis can do, right? On March this year, ChatGPT suffered worldwide outage, right? Not something people usually brag about, but what actually happened, there was a bug in the client library connecting to Redis, right? OpenAI reached out to us. We quickly helped them to fix the problem. But the testament we got from OpenAI because of this incident gave us a great publicity, right? Not only we are responsive and helping ChatGPT to fix problem at the end of the day in the client code, but like ChatGPT is using Redis already. ChatGPT internally would use Redis for things like storing history of your conversations, caching, and so on, right? And there are a few emerging trends that you can see with databases like Redis being used with a large language model. Context retrieval in the context of retrieval augmented generation is one of them, right? But serving as a memory, as a history store for your conversation, or caching the responses from LLM, are two big emergent use cases. And hey, Redis been doing caching since the early beginning, since 2009. Okay. So again, if we look at the production challenges, as you take your little 5 lines of code notebook and move it to production system, right? Azure, with their infrastructure, and Azure OpenAI gives you like probably check majority of these boxes, right? Redis as a vector database, being a first-party service on Azure, again, gives you a vector database that's fully compliant, secured, integrated with Azure Active Directory, providing role-based access control, like everything that you've seen before, right? Redis can be part of that infrastructure too, and frequently is. Right, before I jump to the conclusion, let me see if my last demo has.
Hey, Anton, if you don't mind, we're running behind schedule. So if you could just conclude, I think the key takeaway is very much that as we go into this deep dive in vector databases, the key thing everyone needs to be aware of, there's lots of things under the hood when you're deploying OpenAI, and you need to be aware of, much like we saw that complicated chart from Kyle from ReadApp, talking about all the complexities of tying together. You just need to be aware of how you structure these things behind the scenes. It's another important tool to be aware of. So when you do deploy OpenAI, this is more from a performance standpoint, as well as it can support your security and compliance. That's really my key takeaway. Maybe if you could summarize a few other things, Anton.
Yeah, Ron, you're absolutely right. One thing is to create a simple Hello World application in your notebook, and it's totally different level of complexity to move it in production with all the security, compliance, performance, and high availability requirements, right? And combination of Azure OpenAI, and Azure Cache for Redis Enterprise is a perfect match to bring your retrieval augmented generation solution to the production quality that would stand test of.
Yeah, exactly.
compliance.
My key takeaway in providing speakers and content, and quite honestly, some recommendations, is we encourage everyone, when you're looking at your solutions, all of you need to be more of a strategic architect. You want to understand these solutions and try and piece it together, as opposed to doing this yourself, because it's just too freaking complicated. There's going to be problems occur. And, that was great stuff. Anton, if there's anything else, let me know, but we encourage everyone to follow up. Again, Redis, people are familiar with the open source platform, but when you're looking at these kind of solutions, much more complicated in the world of OpenAI, ChatGPT, vector databases and whatnot, you really need to take advantage of their enterprise grade platform that provides you the services, security, support you need. Anything else here, Anton? Or
No, I think I'm done.